Welcome to aminacademy.com. In engineering thermodynamics, let us discuss first law of thermodynamics. What is first law of thermodynamics? The first law of the thermodynamics states that heat is a form of energy and thermodynamic process are therefore subject to the principle of conservation of energy. This means that heat energy cannot be created or destroyed. It can, however, be transferred from one location to another and converted to and from other form of energy. Look at here. The change of internal energy of a system is equal to the heat added to the system minus the work done by the system. That is delta U, that is change in internal energy is equal to heat added to the system minus W, that is work done by the system. The first law of thermodynamics, further explanation. It is observed that when a system is made to undergo a complete cycle, then net work is done on or by the system. That is, when heat is supplied to the system. That is, it is observed that when a system is made to undergo a complete cycle, then net work is done on or by the system. Consider the cycle in which net work is done by the system. Since energy cannot be created, this mechanical energy must have been supplied from some source of energy. Now the system has been returned to its initial state. Therefore, its intrinsic energy is unchanged and hence the mechanical energy has not been provided by the system itself. Now, in other way, we can define the first law of thermodynamics like when a system undergoes a thermodynamic cycle, when the net heat supplied to the system from the surrounding is equal to the net work done by the system on its surroundings. Therefore, you can see first law of thermodynamics. Like integral whole sum delta Q, change in internal energy is equal to work done, where integral sum is called sum for a complete cycle. Sum for a complete cycle. The first law of thermodynamics cannot be proved analytically, but experimental evidence has repeatedly confirmed its validity. Now, some other definition. Heat and work are mutually convertible, but since energy can neither be created nor destroyed, the total energy associated with an energy conversion remains constant. One more definition of thermodynamics. No machine can produce energy without corresponding expenditure of energy. That means there is no chance to run the machine without energy supply. It is impossible to construct a perpetual motion machine of first kind. The work input to the pedal wheel is measured by the fall of weight in experimental, while the corresponding temperature rise of liquid in the insulated container is measured by the thermometer. It is already known to us from experiment of heat transfer that temperature rise can also be produced by heat transfer. Now, first law of thermodynamics we can understand clearly by repeating the definitions one more time. Look at here. When a system undergoes a thermodynamic cycle, then the net heat supplied to the system from the surrounding is equal to the net work done by the system on its surroundings. One more definition. Heat and work are mutually convertible, but since energy can neither be created nor destroyed, the total energy associated with an energy conversion remains constant. Other way we can explain, no machine can produce energy without corresponding expenditure of energy. That is, it is impossible to construct a perpetual motion, that is continuous motion of first kind. So far we discussed about theoretical part of the first law of thermodynamics. Then future videos we will discuss further about its application in various fields. If you have done, please subscribe our YouTube channel.